8, right? Now we are going to study 4 modules. So far in every part we were studying 3 modules, and now looking at your interest, I feel we should take 4 modules. So in this we are going to conduct 22, 23, 24 and 25. So please pay attention. Just before, what we have studied, velocity of satellite. So based on that we have to see the numericals, right? So critical velocity of satellite formula is under root Gm upon R plus H. Here square is not mentioned on R plus H. Huh? Yes. So please pay attention. In the last episode, prior to satellite, whatever we studied, there R plus H square was there, right? That was for acceleration due to gravity above the surface of Earth and at the depth of the Earth. ऐसे questions थे. But now whatever we are discussing is about satellite. Yes. So it has again 2 parts, at height and close to surface, right? You people have answered in the last MCQ. I hope you remember. Yes or no?
Yes, sir.
In the last part we have seen the question, if the object or satellite is close to the Earth's surface, then what must be the formula? Vc is equal to under root of Gm upon R plus H will be cancelled. Critical velocity in terms of acceleration due to gravity. Please pay attention here. So that is under root of Gh R plus H. So these are the prerequisite information needed for solving numericals. Again, for this we have 2 options. At height, so R plus H hoga, and if it is close to surface, then only GR. Height ही नहीं है ना, so it will not take a suffix of H even. It has only G and R, under root of G R. Keep this in mind. Okay. Now question number 1. Find the height of the satellite from the surface of the Earth whose critical velocity is 5 km per second. Capital G is mentioned over here. Even though they have not mentioned, we have to recall that and we have to write it. Mass of Earth is 6 into 10 raised to 24 kg and radius of the Earth is 6400 km. So we will note down the given very quickly. And what to find? H. What to find? H. Okay? Yes. Now, we'll see the solution. Vc is equal to under root of Gm upon R plus H. Why? Because they have mentioned, see here, R plus H is equal to Gm upon Vc square, or V square C or Vc square, one and the same. C is the suffix. R plus H 6.67 into 10 raised to minus 11, capital G का value, then mass of the Earth, and then critical velocity. Okay, यहाँ पर numbers mess हुए, right? So for that we need to understand what is written over there. So pay attention. What had happened, you know? What was the formula? R plus H is equal to Gm upon Vc square. Now what was the G ka value? This was the G ka value 6.67 into 10 raised to minus 11, that we have written here, and then mass of the Earth, that is 6 into 10 raised to 24, right? And Vc square. So what is VC? VC was critical velocity was 5, but उसका square. So directly we have mentioned 25 into 10 raised to 3 kilometer था ना?
Yes.
See how was it? 5 into 10 raised to 3 the whole square. तो इसको हमने क्या किया? 5 का square 25, 3 2 6. I hope you understood.
Yes.
So it is 25 into 10 raised to 6. So after calculation, we will see what comes. So that is, you can calculate that and you will get the answer 16008 into 10 raised to 3 minus R. Why minus R? Because we need to find only
H.
The answer for this calculation is 1.6008 into 10 raised to 7, but we have to subtract this R from this value, so we will get H, and that H is 9608 into 10 raised to 3 meter. That was our answer. Next question. Show that the critical velocity of the body revolving very close to the surface of planet of radius r and mean density rho is given 2r under root of pi rho g, that is rho, that is not p, rho g by 3. Now see here, if you will think about the proof, first of all we have written Vc is equal to under root of Gm upon R plus H. Also M is equal to V into rho. So what is rho? Rho was given 2R under root pi rho G by 3. So what had happened to this? Pay attention here. Yes. So what we have done, here they have given 4 pi R cube rho by 3. अब ये कंफ्यूजन है कि सर वो वहां पर कुछ अलग दिख रहा है, यहाँ पर कुछ अलग दिख रहा है, राइट? Why so? स्क्वायर रूट तो ठीक है, बट m के साथ अगर मुझे रो का वैल्यू लेना था तो व्हाट इज एक्चुअली नीडेड हियर? आई मस्ट हैव टू टेक रो 2r under root of pi rho g by 3, right?
Yes.
So इसको हमने कैसे लिखा है? ध्यान से देखो, क्या चेंजेस किए इसमें? इन दोनों को क्लब करके इसके अंदर लिख दिए, राइट? तो क्या हुआ? VC G तो वैसे ही है, M का वैल्यू क्या था? V into rho, सो उसे क्लब करके वहां पर लिख दिया. Since body is revolving very close to the surface of planet, so here what will get neglected? I'm sorry. Oh, sometimes having smartness is also difficult, right? Okay. Critical velocity Vc under root of Gm R plus H, M is V into rho, and rho is what? Mean
2R pi rho g upon 3.
So clubbing this two. Here H is very less than R. right? So here r cube and this r got cancelled.
Yes.
One r and the bottom r will cancel. So rho pi rho g is here.
Yes.
4/3 था तो ये 3 नीचे चला गया. Instead of 4 what we have written 2 का square, right? तो अब क्या हुआ, ये भी स्क्वायर में ये भी स्क्वायर में. So now see what happens. 2r we have taken out from the root and the formula is BC is equal to 2r under root of pi rho g by 3. BC is equal to 2r under root of pi rho g. So that was we need to prove, right? Where we got confused that was given, but it is not given. It is we have to prove, right? What is the value of v into rho? That is 4 pi r cube rho by 3. So putting that we have to prove the given equation. So here ends the model number 22. Now model 23. Time period of satellite. Period of revolution of satellite. So what is the definition? The time taken by a satellite to complete one revolution is called periodic time. Right? For one revolution, time is equal to time period. For one revolution, time is equal to time period, and distance is equal to circumference. Distance is equal to circumference. How? Because if satellite starts from this point, it has to come on the same point again. So it is one circumference or circumference, whatsoever it will revolve. The distance is a circumference of that circular path. And velocity is equal to critical velocity. Velocity is equal to critical velocity. Period is equal to circumference of orbit upon critical velocity. Pay attention. What it is? Period is equal to circumference of orbit upon critical velocity. Critical velocity. याद रहेगा?
Yes.
सर अगर ये याद नहीं रहता है तो कैसे याद रखेंगे? So we know the basic formula of velocity is equal to what, Chetan? Velocity is equal to
Displacement upon time.
displacement upon
Time.
which we have studied in 9th standard.
Yes.
So here the displacement is nothing but circumference and time is nothing but period, time period, right? So time period, now if I arrange this in terms of time, so time is over here and velocity will go there, right? So here I can write time is equal to displacement upon velocity. So same formula they have mentioned over here, only in terms of circle they have mentioned period, that is time, is equal to circumference of orbit, that is displacement, and critical velocity instead of velocity. I hope it is clear now.
Yes.
So t is equal to 2 pi r. Circumference of orbit or circumference of circle is 2 pi r. But we see critical velocity is gm upon r, right?
Yes.
So this r will not get cancelled. This will go up and that will be multiplied. But here under root is given, no?
Yes.
So while taking it up, so complete root में अगर मैं लेता हूँ तो r का r cube कैसे हुआ? कोई मुझे बता सकते हैं?
R root के अंदर r square.
r square, बरोबर? वैसे ही बाहर. So if we will take a square on all, so that is t square is equal to 4 pi square r cube upon g. It means t square is equal to r cube. Looking at this, which law can be derived using this? Kepler's third law. याद आ रहा है Kepler's third law?
Yes, sir.
The time period, square of the time period of that revolution is directly proportional to the semi-major axis cube of semi-major axis. The square of the period of revolution of a satellite is directly proportional to the cube of radius of its orbit. Radius of its orbit. It means जब हम लोग Kepler's law में जाते हैं तो that became semi major axis. Major axis का half semi major axis. Time period in terms of acceleration due to gravity. T is equal to 2 pi r cube by gm. So it is close the surface. T is equal to 2 pi root r cube gm. So everyone can note down this along with me. So here value of gm we have replaced with g r square. तो ऊपर एक r cube था तो उसमें से r square में से एक r square cancel. So remain is 1 r. Note down. So here the value of t is 2 pi under root of rg, right? And what is the value of capital R? Radius of Earth, we are aware, 6400 kilometer and g is 9.8 meter per second square. So the time period, if it is close to surface, then it is 84.6 minutes. ये आपको याद रखना, right? What is the time period? 84.6 minutes. Time period in terms of acceleration due to gravity. If the object is close to the surface. Now moving ahead with the same formula. At height, this formula is for close to the surface and this is for at height. Only changes, instead of small r we have mentioned r plus h. Right? So time period of satellite is given as, what must be the answer? T square equal to r cube. ये गलती से ऊपर चला गया, अदरवाइज यहाँ पर करेक्ट आंसर किया, टिक मार्क आगे चला गया, राइट? दिस इज द करेक्ट आंसर. Here time period of the satellite close to the surface of Earth 84.6 minutes. So we have completed the part 23. Now we have to complete 24. Communication satellite. What it is? It is an artificial satellite which is orbiting the Earth in a same direction as direction of Earth spin and having the same period, right? As the period of rotation of Earth is 1 day, so what will be the period of rotation of communication satellite? What is mentioned? Artificial satellite which is orbiting the Earth in
Same direction.
as the direction of
Earth space.
and having
Same
Same
period.
period.
same period or as the period of rotation of Earth. So what was my question? What is the period of communication satellite?
Same as the
Same as the period of
Same as the period of rotation of Earth. So that is
1 day.
1 day, 24 hours. So sometimes it is called as what we can say, the three major satellites which are covering the all the sides of the Earth, means if this Earth is a geostationary satellite,
Yes.
three satellites will be there which will cover the whole area of Earth. Satellite number 1, satellite number 2, satellite number 3. The satellites which are revolving with the same revolution of Earth are called as
Geostationary satellites.
geostationary
Satellites.
satellite. So every country has its own geostationary, has its own communication satellite, but for complete world we have 3 geostationary satellites
Yes.
to cover a complete Earth. Is called as communication satellite. Communication satellite appears to be a stationary when observed from Earth's surface and known as geostationary satellite. Its motion is synchronous with the rotational motion of Earth, so it is also known as geosynchronous satellite or synchronous satellites. Right? It may ask in the examination, the geosynchronous satellite is options. One which is revolving along with the same time and same orbit, same rotation and same period. Now, the height of such satellite from the surface of Earth is about 36,000 kilometers. So if we have T 24 hours, we have G. Now see what we have, height 36. So we have H ka value, R we are aware, radius of Earth, G we are aware, universal gravitational constant, M we are aware, that is mass of Earth. So we can easily so R plus H 40 to 4,400 kilometer, and if we will subtract R from this, we get H 36,000 kilometers. So the height of such satellite from the surface of Earth is about 36,000 kilometers. Now, application of satellite. What all the applications for satellite? Transmission of television, radio waves, right? Whatever communication technology we are using is connected with satellite. So satellite is broadcasting all the signals to us, and with the base station we are receiving that at our user end. For military purpose, for weather forecasting, meteorological purpose. Now, it's time to understand polar satellite. What is polar satellite? Polar satellites which circle the globe in the north and south orbit, passing over the north and south pole, is called as polar satellites, as you can observe here, which revolves north and south. Polar satellites are at low altitude, that is 500 km to 800 km. Time period for polar satellite is 100 minutes. Hence it crosses any altitude many times a day. Right? So ये बहुत important है याद रखने के लिए. This question may be asked in CET. The time period of a polar satellite is what? So they may confuse you by giving option A 24 hours, option B 1 hour, option C 100 minutes, option D none of the above. So you will 100% get confused कि सर 24 आवर तो रेगुलर पीरियड है, 100 मिनट में कौन सा सैटेलाइट रिवॉल्व होगा? सो पोलर सैटेलाइट रिवॉल्व्स इन 100 minutes. Keep this in mind. And communication satellite and polar satellite, which we have studied. Communication satellites are horizontally revolving and polar satellites are vertically revolving. So geostationary satellite has a time period of 24 hours, right?
Yes.
Geostationary satellite revolves at a height of 36,000 kilometer, right?
Yes.
We may get confused with 6400 kilometer and 3600 kilometer, but it is not like that. It is 36,000 kilometer. Communication satellite always revolves in which plane? Equatorial plane. So here ends the module 24. Now it's time to look for model number 25. Numericals based on what we have studied so far. Period for a satellite T is equal to 2 pi r cube upon gm. If it is for height, then that r became capital R plus h whole cube. Now again we have two options, at height and close to the surface. At height, what will be the formula? As we said, r plus h the whole cube upon gm, and it is close to the surface, then same formula, right?
Yes.
Now time period in terms of acceleration due to gravity, that is T is equal to 2 pi under root of r upon g. Again it has two parts, at height and close to the surface. At height, what will be the formula? R plus h upon gh. And next, right? Keep this in mind, here is no square or cube, right? It is just for time period in terms of acceleration due to gravity. So question is, what would be the new period of rotation of the earth around the sun if the distance between the earth and the sun is doubled? What is the question? If the distance between the earth and sun is doubled, new period of rotation of earth वो निकालना है हमें. So R2 is equal to twice R1. T1 is 1 year. T2 is formula. T square is directly proportional to R cube. So what we have to find? T2 square by T1 square अगर हम लोग करते हैं, if we compare this two, then it means we are comparing R2 and R1 also, right? So taking this T1 square on that side, we have value of R2 is 2R1, T1 is 1 year, right?
Yes.
Revolution of Earth, complete revolution of Earth is 1 year. So T2 square is 8 under root of 8 2 root 2. अब एक्चुअली यहाँ पर कंफ्यूजन क्या होता था, अगर ऐसा कहा गया the distance between the earth and sun is doubled, तो शायद some of you might think if for a regular distance, if Earth is revolving in a 1 year, so if the distance got doubled, so it may revolve in 2 years.
Yes.
You might select 2 years,
2 years.
but it is not like that. So exact calculation is 2.828 years. If the distance between Earth and Sun is doubled. तो 365 उसके साथ मल्टीप्लाई करो तो हाउ मेनी डेज 1032 डेज. अगर गलती से ऐसा हुआ तो हमारा ईयर कितना होगा 1032 डेज. सोचो 365 डेज में तुम्हारे 2 सेमेस्टर हो रहे हैं. 365 और थोड़ा ज्यादा तो शायद 5 सेमेस्टर्स होंगे इन एन ईयर. खत्म है ना. तो ऐसा नहीं होगा. Compare the critical speeds of two satellites if the ratio of their periods is 8:1. Which ratio? Critical speeds of two satellites. So T1 and T2. To find VC1 and VC2, we have formula T square is directly proportional to R cube. So we write T1 square is directly proportional to R1 cube, T2 square is directly proportional to R2 cube. Comparing these two, we have T1 and T2 का ratio 8:1, 8:1, and so taking square root, it became 4/1. But sir, R1 upon R2 का cube है. Here you have directly mentioned R1 by R2. Is it right? Because it is proportionality. What it is? Proportionality, right? So whatever will come over here will be proportional on that side, right? So now 1/4. While writing here, we have not mentioned square, cube, root, but actually formula is VC1 upon VC2 is under root of R2 by R1. So taking reciprocal of this 1/4. Therefore, VC1 1/2 is a answer. Final answer. Next question. A Saturn year is 29.5 times the Earth year. How far is the Saturn from the Sun in the Earth is 150 into 10⁸ kilometer away from the Sun. So we are comparing two planets, Saturn and Earth. So what is the time period of Saturn? That is 29.5 times the Earth's year. They have not exactly given the time period of Saturn's revolution. They have mentioned it in comparison of Earth. So revolution of Earth we are aware of, or they have given already. That is 150 into 10⁸. What we have to find is RS. So for that we will compare the two T1, T2, time period of both and radius of both. So what is the solution? RS is equal to RE TS by TE. Same comparison ही है ये. So we have just arranged in terms of R2. Actually what we have done, Hitesh, same formula we have arranged in terms of R2. So this R2, if this R2 goes on this side, then this bracket will go in a reverse way. That is T2 by T1. Clear?
Yes.
So instead of T1 and T2, what we have mentioned? TS and TE. So for this case, RS is R2, RE is R1, TS is T2, and TE is T1. Clear?
Yes.
Now putting the values. So we got the answer 14.32 into 10⁸ kilometer. I'll repeat this again. What we have done is instead of T1, T2, we have mentioned TE by TS square is equals RE upon RS cube, right?
Yes.
While arranging in terms of RS, if this RS goes here, this complete bracket will go here in a reverse way.
Yes.
So TS upon TE, TS upon TE. Clear?
Yes, sir.
So here ends the last module of part 8, right? In part 9 we may look for further modules, right?
Yes.
But as this part is longer than the previous one, you all have to revise it again because we have covered 4 different modules in it. Don't forget to revise. Go and watch that video again. Note down few parts which are related to numericals and derivations so that for the next part we can easily answer the numericals. Okay?
Yes.
Thank you so much.